Everyone, and welcome to today's first webinar of 2026. For those joining us for the very first time, my name is Alina Bonadonna, and I'm super happy to be your moderator today. And today we have just insane, distinct pleasure to welcome as the first speaker of the year, François, a highly respected expert in food safety microbiology with over 20 years of experience across industry, research, and international standard setting. Hi, François, how are you?
Hello, everyone. Thanks, Rina. Doing well. Happy New Year to everyone.
So happy to see you with us, François. And it's actually one of the best beginning of the year to start with such experienced professional like yourself. From where are you talking to us now? Because we have global audience and it's curious.
Yeah, so it's a global audience, and I'm speaking from the countryside in France where I do live. So that's a small village in the southwest of France, near Poitiers. But we have an internet connection, as you can see.
Yeah, that's good. That's good. So, and so far I see that we have attendees from US, Europe, Australia, Asia, basically from all parts of the globe. And a lot of people will listen to us afterwards in recording. So, just before we start, I would kindly ask everyone to share, smile, thumbs up, or any other reaction to let me know that you hear us well and see us well. Okay, Francois, there are a lot of hearts that are coming already at the beginning, and we haven't started even yet. Afterwards, when you stop sharing screen, you will see all of these appreciation hearts to you.
Okay.
So, a huge thanks to Nemis Technologies for supporting our Nemis Academy. And I do believe that this project is going to scale even to a bigger value, not just bringing webinars and courses. And without further ado, Francois, stage is yours. Enjoy
Okay.
your time. Yeah.
Thank you, Alina. So, hello, everyone. Thank you, Nemis and the Nemis Academy, for giving me the tribune today to share my return of experience of implemented rapid microbial methods on the field, and precisely in Sodial, which is a major player in France of the dairy industry. So today, what we will cover is was explained in the promoting posts on LinkedIn: strengths and limitation of traditional microbial methods. Bear in mind that I'm coming from the Pasteur Institute, so I am a big fan of Pasteur methods. Does not mean that I'm not aware that they have limitation by design. It's important also to highlight the huge move of rapid microbial methods in the present years, and also how they are transforming quality and safety workflows for faster decision making. Having said that, there are new tools, there are new techniques, which mean that we need also to consider how to implement them on the shop floor. One thing also that we do need to consider in France are regulatory limits. It's the freedom to operate. It's not because we want to use the methods that it will out of the blue be accepted by the authority and that we can go directly from decision to implementation without any second thought. And all of this in 30 minutes. So let's talk about it. I will briefly present Sodial. My apologies, we are French, based in France. We have 51 factories, 50 are in France, and one is in Quebec, the French-speaking side of Canada, which means that our working language is French. We are owned by the farmers, more than 14,000. We have 9,000 collaborators. And in France, we are representing 20% of the harvest of raw milk, which means that we are quite a key player in France, but not necessarily that well known in the rest of the world. And we are still a relevant company, worrying around 6 billion euro revenue. We are working at every step of the dairy industry, from the farms down to commercialization of direct products. And we are very proud to have 20 PDO cheeses in also 18 shops, internal shops from our factories. Now back to the boring things, the Codex Alimentarius. When we speak about methods, we need to have in mind that they are not decided out of the blues. They are part of general guideline for microbial criteria, and in the components of a microbial criteria, the analytical method is part of the criteria. What does it mean? It means that if you decide to change the method and to go for another one, basically you're not speaking about the same microbial criteria if the performance parameters are different. An example based on culture-based techniques, we also have this decision either we work with plate-based method on the Petri dish, or we work on the most probable number on broth. And we know that even so, this is culture-based microbiology, whether you're working with broth or Petri dish, you can have differences. So it's important to have in mind that when you change the method, you might change the criteria, which means that you might have to change the limits. We recently had a huge work for several years within the International Dairy Federation about all the set of methods for enumeration of thyrobutyric spores, namely Clostridium butyricum and Clostridium thyrobutyricum. There is no reference method for this one, which means from one country to another, we have a different set of limits based on different methods. It's also important to have in mind what we understand by the microbial criteria. This is a work that have been lasting over the past 40 years. The first definition of the microbial criteria was in 1981, and it was basically border control. You work on finished products, this is acceptance and non-acceptance of the food products. Yet we know that you cannot base your decisions solely on the finished product testing. If you have 80 tons batch of milk powder and you test 750 grams, does not mean it will be fully representative from your whole batch. And now we modified the guidelines, most recently in 2013. It took 5 years to do so, and we try to promote away from finished product testing to process control, testing where it makes sense, and also asking yourself a question: do I need to test using a micro criteria, or are there other limits I might want to follow? In Europe specifically, sorry for the non-European audience, I didn't check all the regulations worldwide, but in Europe, we have a specific regulation for setting microbial criteria for foodstuff, the EU 2073/2005, and we've got an Article 5 specific rule for testing and sampling. This is where it is mentioned that in the Annex 1 of this regulation, all the ISO referred methods should be considered reference methods, which means that in order of trade barrier, in order of selling from one member state to another, you have to use the reference methods. Still, there is one possibility to use what we call alternative analytical methods, or sometimes also called proprietary methods, provided that they are validated against the specific ISO scheme 16140 part 2, and also that this is done by a recognized operator. You still have a possibility as a food business operators to use analytical methods that are not validated, not certified as such, which is brand new. At some point, you need to have recognition from the competent authority. And so far in Europe, we have very limited, and I don't think we have a lot of methods which are not validated against the ISO scheme, which are recognized by competent authority. So this is really a must-go barrier to go through all this validation scheme if you want to use the method, whether it's culture-based or whether it's a rapid method. There is also this issue with the reliability of finished product testing. My apology for the poor capture of screening, but this is quite an old publication, difficult to have. When it comes to salmonella testing in milk powder, we often refer to this study from Abraken from 1986. He was quality manager at Friesland Campina. That's one of the first publications promoting process control rather than finished product testing. And in the introduction, Abraken started by mentioning that the testing on finished product was known by microbiologists not to be reliable, which means that the method is nice, but it does not provide everything you want to know about the quality of your whole batch. Whether you're working with culture-based or you're working with rapid microbial methods, what is important is not to start with the technology per se and compare one technology to another, is to start with the why, not the how. And the first question you need to ask yourself, is faster time to result needed from a business perspective? Some years ago, working from another dairy player, Savencia, I worked on implementing molecular microbiology in the labs in order to provide product release within 24 hours. Took some time to work on accreditation. Very happy to be the second lab in France to be accredited against molecular criteria. You come back to industry and they explain you that the cheeses needs to be cooled for 48 hours before being delivered. So 48 hours, as we already had, was fine, and we don't need 24 hours to results. So it can be interesting to develop a faster methods, but if you don't need it, that's basically a waste of time. It's also important to consider the return of investment. As a laboratory, every time you are proposed a new methods against referential culture base, usually it's more expensive from one test to another. So basically you might say, why should I pay more? But it's important to make a calculation of the return of investment for your company. That's example I take often is the implementation of molecular biology within the chocolate industry done by Barry Callebaut in the early 2000s. Back then, testing on molecular technique with PCR for salmonella was quite expensive compared to culture-based. But on one side, you had to store the product for 5 days. On the other side, within 24 hours, you could release. The return of investment was around 3 weeks for acquisition of the whole techniques, which means that you end up in most of the chocolate facilities of Barry Callebaut around the world, more than 50 of them, with molecular testing for pathogen, because it helped to have a faster techniques. But going once in a facility in Indonesia, at the same point, you had a molecular equipment in order to release within 24 hours salmonella, and you had people cleaning glass petri dish, because it was cheaper to use glass petri dish for hygiene monitoring rather than really go from plastic petri dish. So in this case, if already in the 2000s people are still using glass petri dish because it's more efficient than plastic petri dish, this is pure science fiction to come with AI technology with photonics for them. It's important to understand what's the return of investment. Another issue that we need to consider when we are implementing technologies in the lab is the capability from the team to use the technique. And as such, it's very important from the analytical suppliers to be able to train and to support the implementation of the technique within the lab, because we, as routine labs, we don't necessarily have all the time to train on a yearly basis all the technicians on new techniques, which means that a change of techniques means a change of capability from the labs, and training is needed. And of course, if you use a new techniques, is it regulatory approved? And sometimes does it need to? When it comes to food safety criteria in Europe, it's very strict, it's very, very restricted. And if you don't have validations, clearly it's a no-go, it's a no-brainer. No one is going to use non-validated method for pathogen testing for food safety criteria. Now, when it comes to hygiene monitoring, that's different, because the decision will be different in terms of non-compliance. You do not need necessarily to recall or block the production. It's more shift in cleaning regime. So that could be something where regulatory approval is not needed as much as it could be. Choosing a microbial methods, it's defining the needs for the most relevant tools. And that's a publication I made in 2014 with my team from Barry Callebaut. And I'm afraid that the points are still valid 12 years after. And by the way, if they are registered, I'm saying hello to my former Barry Callebaut colleagues. What is important is to consider the time to result and the high throughput. If you are provided with a molecular techniques that can do 500 samples a day, but basically your routine scheme is around 15 samples a day, do you really need this? Not so sure. So sometimes people come and ask us that they could bring a robot with a molecular assay in order to have a faster throughput, but basically you don't need this. It's very nice, it's very beautiful, but you don't need this. What is important, and that was very much an issue in 2014, now it's less an issue with the 16140 part 3, the verification standard, is a food matrix interference. When you work with 99% cocoa, I can assure you that DNA polymerase is really an issue to make an application of the DNA sequence. It's important to know the basics. When you change the method, it's important to know what your method was doing and not doing. And we always, at some point, need to go for isolation of suspicious colonies. So that's why, even so, by design, there are some limitations and you do not recover everything. Pasteurian microbiology remains a must-have. I will give you an example, not directly related to food, but what we do have presently in France with Legionella testing. We have two standards recognized by the authorities for Legionella testing. One is a 431, which is Pasteurian based, and it's official. And one for screening is a 471, which is molecular based. But whenever you use a molecular base, there is no possibility to get back to the strain, to isolate it, to have the whole gene sequencing, to know for epidemiologic purpose if you're working with the genera that could be implicated in an ongoing outbreak. So whether we want it or not, at some point for food safety criteria, there is always the need to have it on a petri dish for further studies. The ISO 16140 validation by design, it's a no-brainer. We need to have it. It's also important the choice of the supplier to, of course, the cost is very attractive, but what is more important is the service. Mostly for major companies, when we decided in a central lab that for one criteria, we're going to do these techniques that's going to be valid for all the labs, it's important to have in mind that central laboratory for evaluations have a lot of PhD people and they've got a lot of space. It's not the case for every factory labs. And also depending on the print of the company where you are located, it's also important to choose rightfully the supplier. If you choose a local supplier which has limited service capability outside the region, like outside Europe, and you want to implement the methods in Asia or in Americas, and there is no service support, when the machine breaks, then you cannot release the product anymore. So it's important to have in mind that whenever you use a technique, contingency planning is needed, because if there is a nice equipment that delivers very fast, it can also break. And if it breaks and operation is used that you deliver results within 24 hours, they're not going to understand that you will have the machine repaired in the next 2 weeks. So it's also a commitment that you need to make sure, and therefore you need to implicate sales in building the contract with your supplier, that contingency planning is in place in case of break of equipment. So it's more than method evaluation. It's really considering the service globally as it is. For the microbial method implementation, the scheme is very well defined. First is to check if you are using a reference method that is being duly validated. There was a huge set of validation of reference methods in 2017 with publication for the major pathogen of concern for the major food safety criteria. There are still some methods now in microbiology from the ISO TC34 SC9 that do not have this 17468 validation, but it's changing a lot. Afterwards, you need to check for the validation of the alternative methods. There is the globally recognized scheme is 6140 part 2. What can be different is a certification step, whether it's done by AFNOR, Microval, Northwall, or IOSC. Having in mind, what is important is when you have the validation of the alternative method, it's validated against a reference method. And in the EU regulation, you need to have a validation against the reference method. It can be AFNOR, it can be Microval or IOSC, that's okay, as long as the validation is done against the ISO standard and not the US FDA BAM. So it's important also in the validation scheme to make sure that the method has been validated against your reference method in your regulation and not another regulatory approved standard. And this can be an issue in global trade, because ISO, even though it starts with International Standard Organization, it's not recognized in every countries. You've got specific standards in North America, you've got specific standards in Asia, and the authorities recognize, which is normal, their local reference methods. So what is recognized on one region might not be on the other. It's important to consider what the method was made for, the scope of the methods, then the scope of the validation, if your product is part of the validation, and also the way you are using it in the lab, if it's done according to the validation. Can be sometimes discussion you have with the size of the sample. In powdered infant formulation, for example, we try to make sometimes some dry pooling. So taking all samples from 25 grams and having a composite samples of 375 grams, you have to make sure that the method has been validated for this. ISO methods are not meant for dry pooling. So if you want to use, for example, for Salmonella, the 6579 part 1 and huge size sample, that's not part of the method. Then it's important to know what's the ongoing work doing on the validation scheme between these different methods. And you've got the ISO TC34 food, SC9 micro, WG3 method validation. And for now, it's my colleague Paul Invelt from the Netherlands, who's the convener of this group. And it's very relevant, even if you're not a member of this working group, to follow what is going on there, because we have really extended the scope of the different 16140 series. I wonder how many parts we have now. It's always moving. I think we are part 9 or 10. There are many different types of methods that do need a validation in order to make sure that they can be used properly. Also, as the lab manager, if you want to use new methods in your lab, it's important to make sure that it will be accepted by the one who are going to use it. It's not because you are interested in the method or you've got an ethical supplier who propose you a very nice scheme. At the end of the day, you are not the one doing the testing. It's the people from the labs. Personally, I was kicked off of my labs some 10 years ago because they explained me nicely that theory was my game, but practically I was not accurate enough, so I had to get out. But it's important whenever you choose a new method to make sure that it will be also accepted by the people who are going to use it. And this very clear example can come from the way Petri film or this type of alternative method can be used. In the 90s, 2000s, Petri film as a new technology was getting a lot of attention and replacing in many labs Petri dish. And some labs were by design resilient to change because they were the technicians were not convinced of this technique. So that's why it's always important to make the difference between the theory and the practical, and make sure that for you technicians, for you people, there is added value to everyday's job, which means that you have to anticipate training, and a lot of training. So it's all about capability building. You can switch on paper. It can be very interesting to switch from culture-based techniques to a molecular assay or to flow cytometry. But if you do not train the people, if you do not make them understand how they should interpret the results, for sure you might buy the equipment, but it might stay some days on the bench before it's used, and then it's a loss of money for the company. As an example, some work we have been doing recently within Sodial, working with choosing the right methods for commercial sterility. So commercial sterility, it's something that is, for the moment, not clearly defined within the validation scheme of the ISO 16140. That's something we need to do when it comes to making sure that, in our case, UHT milk is compliant with the regulatory expectations. So that's an extract from the EU regulation on that topic. And as you can see, we need to ensure that the products are stable, which means that once you incubate them for 15 days at 30 degrees in closed container, and then you put a part of the milk on a petri dish for plate count agar, and you add 3 more days, and then you should not see any colonies. So if you make the calculation, it means that if you follow strictly the regulation, once you produce the UHT milk, you have to wait for 18 days before you can release it, if you make the decision based on finished product testing. So I don't know if some of you have ever visited UHT facilities, whether it's UHT juice drink or UHT milk, but 80 days of production, I can assure you it's a lot, and it's a lot of space. So it's very, very costly. Even so, the technique per se is very cheap. It's very costly to have to store many days of production before you release it. So sometimes when you go to these facilities, the storage surface is far, far higher than just the production zone, and it does not make sense per se. So we need to work on alternative methods that can provide the same level of efficacy as the reference method, which in that case will be incubation for 15 days and an immersion of plate count agar. This is a work that was published in 2019 by my former colleagues from molecular method analytics from the Nestlé Research Center, so Benjamin Dieb and his colleagues. And they worked on making a comparison of the available methods on the market and deciding what would be the best candidates for screening for microbial for commercial sterility. And the point is, which is not surprising, but it's always better to put some science on it, there is no perfect method. So in the publication from Diep and colleagues, you have these inclusivity results. And as you can see, based on the 6 methods they have used, there is no method where all the microorganisms that they choose were growing. And also on this list, based on the expectation we do have within Sodial, there are several strains that we need to add on top of that, like Microbacter or Aliciclobacillus. And even then, when we add them, we see that it's not working with every technique. What does it mean? It means that whether it's pasture-based, whether it's RMM, there is always a limitation in the method, and there is no perfect method. So that's sometimes a wording we need to change when people say the total plate count does not exist. Mesophilic count does exist, but total plate count, it's impossible. There is no method where you can test everything. So what we decided to do within Sodial is an adaptation of the hurdle concept, or maybe recently you heard about the Swiss cheese model used for coronavirus. One hurdle won't make it, but if you have several hurdles, then it might be more efficient. So what we decided to go for was a combination of methods based on what we need to test, the number of samples taken for batch release. We have sums on one techniques, mostly based on ATP or resazurine, and we've got other based on different concepts like flow cytometry. And using a different set of methods, we know that none is perfect, but at least the combination provides us more confidence in the compliance of the batch. So that's also something to have in mind whenever you use the techniques. If it's limited, maybe a set is an option. So that's something we can do for hygiene monitoring for UHT milk. Of course, that's not something you're going to do for pathogen testing, for example. That will be too complicated to handle. It's also easier to innovate on rapid method when per se there is no all standard in place. When you have a reference method in place that has been used for many years, there is always this reluctance to change because we've done the job, it was very fine, why should we change? Now, with more and more new food types coming to our plates, the use of new protein sources, of new plant-based products, we do not have standards in place. We see some issues with contamination from unusual bugs, or at least not the usual suspects from the meat analogs. And as such, it's possible to develop rapid methods with new techniques. So in that case, that's a work I was very pleased to be part of within the Università Cattolica and the European Project Titan on nanopore amplicon sequencing for rapid detection of Bacillus spp. So when you have nothing in place, it's also easier to operate. to add new values. Point is, the implementation of new methods take time, a lot of time. And that's another example. If you work with identification of strain, if you think about API gallery biochemical testing, this is so old. It was designed in 1917 by Patrick Grimond. Yes, but it's still working. It's very cheap. It's very efficient. Now, whole genome sequencing provides more information. Does not mean that out of the blue, everyone is going for it. Why? Because the technology is changing a lot. It's not established. And also, it's a huge investment in terms of equipment, but also in terms of capability of your teams. So that's something that's a work that has been led in the past years by Adrienne Klinch and her colleagues from Nestlé, and part of a European network of microbiologists. And we recently published last month in Food Safety Art magazines the perspective on implementation of whole genome sequencing for the industry. And the major hurdle to implementation of WGS in the industry is not the technique per se, is what we're going to do with the techniques. So it's very important also as well to have in mind, if you have a new tool, it must serve existing purposes, or you must be aware what you're going to do with it. Because if it's just a new tool, but you don't know what you're going to do about it, or you don't understand what's the added value, you're not going to use it. So there is a lot of education needed when you have new opportunities through rapid microbial methods to explain why it's important to go for it. And it's always a shared responsibility between different stakeholders, between industry, academia, and innovators, in order to make sure that everybody understands and can make recognition of the outcomes of the results. So you need also to implicate regulators in the decision of implementation of new technique. At the end of the day, whether it's culture-based, whether it is rapid microbial methods, there is always this balance between capability and capacity. Within Sodial, we have internalized capacity for hygiene monitoring, because this is where we can monitor very fast the global compliance of our products, based on either the location of the companies or the sensitivity of the testing or the need for new techniques. It can be also externalized. I'm not going to discuss is whether you need to have everything in-house or everything third-party. It's always a combination of both. What is important to have in mind is that sometimes when you implement rapid microbial methods, there is a need for investment on equipment. If you're not so sure that you will be able to maintain the capability of the implementation of rapid microbial method, then it might be better to work with the third-party labs, and because it will be able to share the cost. As an example, we are collaborating with Charles River for MALDI-TOF identification of isolates of concern, because we do not per se have enough isolates in order to justify the cost of a MALDI-TOF internally. And we can work with third party in order to make sure that they have this capability to give us the results very fast. So you don't need necessarily to have internal capacity, but what you need to have is understand the new techniques. So whether you decide or not to implement in-house the technology, at least know what is it about, because you are the one who know the product, and it's important to be able to challenge your analytical supplier. Else, you might face some issue. And that's something we have seen in 2011 with the so-called crisis on Clostridium botulinum from Fonterra, between Fonterra and Danone, which in fact was Clostridium sporogenes, and it led to a forced recall. And it's very important recently in the US with the CBOT outbreaks, which require specific testing to work with the right laboratory who can provide you insights that you cannot do internally due to your lack of capability. At the end of the day, please remember, this is all about testing. This is also about the representativity of your sampling. And that's something I stole from my colleague Cécile Vadier, because once we had a conference call and I see in the background this image, this capture. If you do not catch anything while fishing, do not conclude too fast that the lake is empty. When it comes to microbiology, absence of evidence is not evidence of absence. And with such, I'm going to conclude. Please have in mind, well, if even so we have new technologies, Louis Pasteur is not dead and will still be here. And by the way, yes, he has a webpage. It might not be him still. I'm still wondering if it's still really him, but at least he's got interesting posts, and I encourage you to follow him. And with this, I conclude the talk and I give the floor to you, Alina.
Thank you so much, Francois. And you see already a lot of reactions are coming. Probably now you can see it, hopefully. And there are hearts, claps, and yeah, a lot of them are coming. And my appreciation to you as well. While we have some questions just probably typing in progress, I would love to be first to who can ask, if you don't mind, of course.
Of course, please.
Yeah, so you mentioned very clearly that there is no perfect method, basically. And how do you see the best balance today between culture-based methods and rapid methods in large daily operations?
It's important to know the limits of the method you're going to use. It's like, example, when I have this first discussion with Nemis about your testing, it's very efficient, it's very fast, but it's complicated if you want to isolate from the sample, the strain, in order to go further. Which means that if you want to use it for fast screening and real method, definitely it's a no-brainer. Let's go for it. Now, if you want to go for epidemiology, for source tracking, for finding the strain, it might require either different methods of different capacity to extract the DNA and look further. So it's important whenever you use the techniques to know precisely what it can provide and what it cannot provide in order to know how you're going to use it. So it requires still some expertise and setback from the lab. When you decide to use the techniques, you know what you can do and what you cannot do with the technique. So it's very important to take some time to go in the technical dossier to look further. There are always added value to these rapid methods, but there are some limitations you must be aware of.
Yeah, for sure. And what would be the best process of evaluation and implementation of such rapid methods for big companies with most, I would say, complicated organizational structure?
For big companies, their issue, and I won't say any name, but I've been in these companies before, is more to be aware of the limitation of your facilities rather than the methods per se. And it's important not to evaluate the technique just because it's nice and very scientifically appealing, but you must know what added value will it bring to the labs, and do I have the capacity to explain by myself to my labs what will be the added value, or do I need support from the company? In my role in Sodial, I am very visible by many companies who come to me and say, I have this technique, I have this technique, this techniques. And every time I have to say, thank you, I understand the concept. So let me discuss with the labs if there is any need, if there is any interest, because I can be convinced by the very interest of the techniques, but if it does not serve any purpose for my labs, I'm not going to move further. And often people tell me, yeah, but this is the new techniques here, but newer is not necessarily always needed. It's important to know what it brings. If can it reduce cross-contamination issue in the lab because there is no positives, there is not strains needed? That's one thing to go. Does it require a full P2 labs? Can it be used for screening? We have this new set of techniques, NEMIS is part of it, when you don't need a full P2 labs to run the tests. So it can be very interesting if you do not have a whole lab to use on a punctual basis these techniques. So I'm often make the decision between routine testing by the local labs and expert testing by a dedicated team, or in case of specific situation where you might come with like a SWAT team and support on a temporary basis your local team.
Yeah, and thank you so much also for highlighting NEMIS as a good example. That's my pleasure to hear as well. I didn't ask Francois for this, honestly, guys, so that was his decision.
I'm just using this example, but I already stated all other techniques as well. So there is no commercial agreement in this. I'm checking. Colleagues from Sodial for me are listening. Check with compliance. No, I have no financial interest in the webinar.
That's great. So there are more and more questions coming. So next one is from also a good friend of ours, Dominique Walch. How can spread the acceptability of NEMIS-like methods for environment monitoring with large companies? Of course, not for release or finished goods.
What is important, and I had some discussion with implementing techniques that people from the start, they told me we need faster methods to release the products, and for the environment, that's okay, working with culture-based. And then by discussing a bit, I say, you know, for your finished product testing, we are waiting for vitamins results or components that takes 15 days. So whether you release by 5 days or 2 days doesn't change anything. Now, when it comes to pathogen monitoring, when you find something, you need to go back to the last time you were compliant, you must take action sampling. And we just made on paper an example, how do you work with an issue if every time you need to wait 4 days for the results, or if you have the results the next day. And in one case, your factory is blocked for 1 month, and in other case, you can solve the mess in 1 week. So it might be counterintuitive because people say faster on products, slower on environment, but in fact, the faster you go in the environment, the less you will lose, you might lose money, because at the end of the day, when it comes to ready-to-eat food, and that's something embedded in the new Codex guidelines on for Listeria in ready-to-eat food, it's important to have a high focus where contaminations might happen, might come, the environment, and not in the finished product. And that's linked to one of the points I discussed, product testing going to process control. There will always be limitation to finished product testing. If you can show that your process is fully under control, then you don't need to go for finished product testing. And we have this set in some guidelines from the Ministry of Agriculture in France, where they show that if you can prove that your process is under control and that contamination cannot occur on your finished product, then you don't need to test for Listeria because it does not make sense. So there are many ready-to-eat products where we do not test for Listeria monocytogenes because it does not make sense in the process to do so. Then we need to show that the process is under control. And pathogen monitoring, process environment monitoring is part of the relevant process control.
Yeah, thank you so much, François. Next question. First of all, thank you for insightful presentation. What do you think the best option adopted in the agricultural context, especially the biostimulants context?
The bio what?
Biostimulants. Stimulants. Stimulant. Yeah.
One of the limitations we have is that people often refer to the 2073-2005 regulations where it explains everything you need to do, and they set a set of criteria, but they forgot that there is one regulation above it, the Article 14 of the 17H/2002, where it's your responsibility to ensure the safety of the products regardless of what you're using. So I think it's important that when you have these new food types, to make sure that your risk analysis is in place. And at the end of the day, it's not necessarily the micro that might be an issue. And we are presently seeing this with the ongoing recall in infant food, where in fact the issue was earlier on in the process and not in the finished product. So it's important with this biostimulants or whatsoever to revise every time your risk analysis and to make sure it stays relevant. So it's really start with the risk assessment every time, new food type, new food process. Is my approach still valid?
Thank you so much. Next question is, why would labs have different results for micro for samples from the same batch?
Oh, so I didn't mention it, but there is a very interesting report from 2010 or 2011 from John Bassett when he was still in Unilever, now he's in Danone, about the impact of distribution of microorganisms on the results. Point is, apart from the starters, so the first starter for fermentation, the microorganisms are always heterogeneously distributed in the batch, which means that there is always an issue with the representativity of the sample. So glad to make another webinar about this. Spoiler alert, is going to be very boring. But yes, we have this issue, and that's why I use this image from Cécile on the fishing in the lab. And this is also a wording that changed in the ISO method in 2009. We do not say anymore presence of absence. We say detected or not detected, because the method is not perfect. And your sample might be with no contaminants, does not mean that the rest is not with a contaminant. And that's something very interesting in the Abraken study from 1986, where he mentioned that by then, Friesland Campina took the decision when they released a batch of milk powder to make sure that at the same time, all the process control, I mean, from the evaporators, from the pasteurizers were compliant, and that the environment was free of salmonella. And when they release a batch, as a lot of us do in infant industry, it's not only based on the finished product, it's based on the fact that all the rest is ongoing. So we have like this finished product dossier where not only the micro, but also all the process controls are compliant. And I hope there are not too many regulators in the audience. The finished product testing is more to please the regulation to show that we've done it, but to know that basically it has limit, and what's important is that all the rest is under control. And yes, we will do finished product testing, because at the end of the day, regulators want to see the finished product testing, but we know that it will never be as robust as showing that all the process was fine with evaporators, pasteurizers, as all going sense.
Thank you so much, François. Listening to you, actually, I think, first of all, we already scheduled the webinar on September, so we still have space to figure out.
We can make a third one, but later,
yeah,
because I still need to do. If my boss is listening, it will come too much time.
Yeah, and then we will do definitely something offline with you. I do believe that audience will support me on this. Give me some reactions, please, guys. So next one, oh, you see already minimum 3, 4, 5 people who are going to attend your offline.
Not good time.
So another question, is there any technical advice you can give when we want to implement rapid test methods, same as Petrifilm? We were offered a product similar to Petrifilm called PetriSteam. How can I make sure that this method is good for being used in lab?
That's part of the verification scheme. It's always, and it's also a call for central labs in major companies. It's not because we believe it makes sense that local labs will agree with it. I have this example ongoing. Once we decide to implement a huge equipment from the central labs to all our facilities, there can be some callback from C to say, thank you, but I don't have the space for it. In one of the cheese labs we do have within Sodial, we needed a robot for molecular testing because there is a very high throughput. And the robot went through the door for 1 centimeter. So we were 1 centimeter away to have to break a wall in order to let the equipment go into. So it's very important to have an approach with the space available, with the understanding on the local team, with the acceptation. At the end of the day, they are the one who are going to run the tools, so they must be fully embarked on this. So I can give you an example which is not related to micro, it's related to safety, occupational safety. And some 20 years ago, we were asking people in the warehouse to use safety shoes, but they did not want safety shoes. So we discussed, and at the end, we found safety shoes on the catalog that were red with a Ferrari logo. And at the end of the day, everybody wanted wanted safety shoes because they were a Ferrari logo. So sometimes you need also to be clever with acceptance. And here's the same point. People, if you want them to understand the techniques, you need to take the time to educate. There is always resilience to change. The culture of the company must be aligned with your decision for change. So it's important, yes, to take time with an ethical supplier to discuss about the techniques to understand, but do not neglect the time you take with your teams, with your people, to explain them why you make the decision, why it makes sense, and make sure that they agree. And if they do not agree, you're not being clear enough, or maybe you took a wrong decision. So sometimes it's also important to decide, maybe on my office, working with whatever companies, we decide it will be a good choice. But then if I face this with the labs, they don't need it. And I know I made this Matex 20 years ago. We worked a lot. We accredited our central labs. And when it comes to the FATI, they say, yeah, nice work, but completely useless. So I think it's important to spend some time with the people on the shop floor. That's what we call the Gemba when reality happens, to know what they need, rather than to come with a fancy new technique that they don't need at all. And sometimes reversely, local labs can say, I have these suppliers because I wanted these techniques. Then you have two options. You can blame him because, why did you call the article? You go to central, but that's not going to work. You should understand, I missed an expectation from my local team. I understand what's going on. And if this lab in my network has the capacity, has seen what it was missing, maybe it's needed for the one. So it's really important to share the return of experience from one lab to another, because if I say to use the techniques, people will say, yes, thank you, François, it looks nice. Now, if I say, I was in Vienna, in Rouen, whatsoever, there are these techniques, maybe you should it, they call to each other, and it's about the trust process. And trust is between people, it's emotional intelligence. This is where I need to improve.
Thank you so much, François. We still have a bit of time and we still have a lot of questions. So I do apologize already to those people whose replies and messages I just skipped, because we are really running out of time. I will forward everything to François, and in case he will reach out to you, and you can also ask him in LinkedIn. Yeah. So the next question, you spoke mostly about contaminants and contaminants, for example, negative microbiological testing. What are your thoughts about beneficial microbes testing, for example, probiotics?
Okay, so that's my other line of work. I'm also working on this. Yeah, in that case, it's a little bit different, because when you work with starters or with probiotics, you expect homogeneous distribution in your sample. So in that case, the representative sample is not a topic. What is a topic is important is how much do you need to distinguish this probiotics strain or mixture from the rest. We have a specific IDF bulletin, so IDF is International Dairy Federation. We have a specific bulletin on this, on identification of probiotics at the strain level. There is this requirement from the authorities that if you make a claim, it must be substantiated by the techniques, which means that you need to prove the presence. That's something that we have by law in yogurt. When you have a shelf life on yogurt, it's not due to safety. It's not due to degradation of the product. It's due to the fact that a yogurt has 10⁶ starters in the product. So at some point, because it's acidic, also the starters are dying. And after a while, when you're out of shelf life, it's just that the starters are not present anymore, which means that when we put a shelf life on a yogurt, we have to show to the authority that the starters are present at the end of shelf life at more than 10⁶. So we have a lot of techniques. And I saw at some point that Pierre Brugière was connected with flow cytometric, for example, where we can use a set of combination of the different starters, because you need to show at the same time that you've got the Lactobacillus delbrueckii, the Streptococcus thermophilus, the Bifidobacterium, whatever Acidophilus might be there. So yes, in that case, definitely, pasteur is out of it, and we need to go for new techniques. And right now, the two methods of interest are one side flow cytometry, and the other one is molecular technique with dedicated assays. We work also with startups like provide us specific primers for set of species that you want to see in your product, which is a way to show compliance of your product. And this is something that is not to safety of the product, but what we call loyalty of the product. If I make a claim to the consumer, I must make sure that I respect this claim. It's about loyalty to the consumer. So yes, for starters, we have a huge set of techniques, and this is all part of the standing committee of microbial methods for dairy microorganisms from the International Dairy Federation, which is chaired by my esteemed colleague Yao Su from China and Grit Fischer from Germany. So
Thank you so much.
It's a work.
Yeah, thank you so much. Next question. In terms of facility lab capabilities versus rapid methods, do you have a recommendation? What would be frequency regarding maintaining accuracy through ring test, interlab results comparison?
So we have recommendation and we have regulation. In France, we have an article from the EGalim law that express that auto control laboratories should either be accredited or at their own cost perform ring trials to show the capability to do the testing. So since all the Sodial labs are in France and it's embedded in the law, it's a no-brainer. We are part of ring trials. The dairy industry in France has built a specific organization for this called CCalais, with my esteemed colleague Philippe Trossard in Franche-Comté, just near when we make the Comté cheese. So very nice, very impressive lab, definitely. And yes, ring trials is a no-brainer. You need to do this. And also in the new 7218 standards, there are also expressions for internal quality control. So yes, it's important at the lab to be sure of what you do, because every time you come to a lab and you need to take harsh decision, you have a pushback from operation. Okay, you're sure about what you're doing, and you want to be sure, because one thing is lab make mistakes. If you don't want to make mistakes, don't do anything. That's the best way not to do mistakes. Now, if you go in the lab, you might do mistakes. So you need to have internal control. You need to show your capacity. In other words, when you come to operations and you say, we need to block this product, you're sure about it? I'm sure about it. And it's no brainer. So yes, there are a lot of control. WGS can be used for making sure for cross-contamination issue, because they do happen. Also in reference lab, they do happen. So it's very important when you have a results that you are sure about the decision making.
Thank you so much, François. And probably the last question for today, still about the same question what was asked before. What would be the right frequency?
The right frequency. It depends. It depends on the size of the labs and depends of the samples we have. Right? Yeah, don't love Jerome. The minimal frequency we ask is twice a year for the labs. Now, we also, apart from this proficiency testing, we have the capacity to use samples with specific values in them that you can buy every week, monthly basis in order to check your technique. So it's important to make the distinction between checking the capacity of your technicians and checking the global capacity of the labs. And it's also very important when you have newcomers that you make sure that they understood what's going on. And sometimes I see that people say, we make in parallel the sampling, they have the same results, so it's fine. I say, no, if you compare samples, but basically you don't find anything in one part, maybe both of you are wrong. So it's important to work with at least artificially contaminated samples or this reference value in order to make sure that if there is something to find, you will find it. But the education of your technician and the maintenance of the education of technician is a very, very sensitive debate, because this is really the key. You can speak about methods, you can speak about lab design, whatsoever. At the end of the day, what matters are the people. Because a lab, an equipment you can buy, but people, it's a huge investment on the long term.
Thank you so much, François. And as I promised, last question for today. How do you approach the issue of biofilms before sampling?
In the industry?
Probably,
So
yes.
biofilms will be mostly for swabbing in. So it's important to have you have techniques for monitoring for biofilms. Right now, we are working with some companies for cameras that can show us where biofilm is in our dough for investigation. It's important to know which type of residues, cleaning agents you might have in your facility because they will interfere with the techniques. And it's important when you make the swabbing. I'm a big blocker when it comes to contact plates because they don't have any mechanical actions and they're not working. So sorry for suppliers of deep slides. No, for me, if you have a biofilms, you need to recover it. You need to have a mechanical action. So either by swabs or sponges whatsoever, but use some elbow oil in order to make sure that you grab the biofilm and seal it. But if you want to check for the sanity of your drains, you're not going to do this with contact plates. That does not make sense.
Thank you so much, François, and thanks to everyone who actively participated in our webinar today. The chat was just burning. I don't know if you felt this, but I do promise to everyone that I will forward everything which was written to a chat, because there were also some interesting comments apart from questions, but questions we covered hopefully all. Maybe a few last things you want to highlight, François, before we close from the topic
I hope I
today.
did not speak too fast because being French and working with the Italian university has this tendency to speak quite fast. So I hope that was okay. And if you have any further questions coming this, I'm very pleased to answer it. As long as we don't breach any confidentiality rules, that's okay.
Thank you so much. And I do wish everyone the smooth start of the morning if you are in the morning hours, and the smooth and pleasant end of the evening if you are also in the same time zones as we. And see you already next week. We will talk about food safety risk optimization. And the link I just published, so you can register already straight away. And yeah, happy to see all of you guys next time at our NEMIS Academy session. Bye bye.
Okay, bye everyone.